slide which I call typical examples of non-subspaces, something we haven't discussed with you. Right now, we have a few methods how we can show that something is a subspace. Direct method, it's the method which is based on the subspace theorem. Second method is when we try to link a subspace to the orthogonal complement subspace. It's the subspace we studied with you on Tuesday. Third method, and when it is the method when we try to link things to the span subspaces. So 3 methods to test that something is a subspace. We haven't discussed much about what happens when we have to test something is not a subspace. And that's on this slide. I collected the basically all typical examples which you see in a yellow book. Normally, when you want to show something is not a subspace, you basically try to show that one of the criteria in the subspace theorem, they fail. If you have 3 criteria there, 0 vector must be in the set must be closed under addition, and the set must be closed under scalar multiplication. If you can fail one of these criteria, you done to conclude that the set is not a subspace. So here's a few examples. 17, that's the one which actually I showed you briefly already. Here's a set in example 17. It's a collection of all 3-dimensional vectors, x1, x2, x3, such that the components of those vectors are subject to the condition like so. We saw this last time. And the immediate, straightforward, and very short argument why this is not a subspace, it is because 0 vector doesn't satisfy this condition. So question 17 fails first criterion of the subspace theorem. Did I make another typo? No? I did make another typo. Thank you very much. Yeah, that's why this is not a subspace. If you want to fix this, problem, if you want to convert this into a subspace, the quickest fix will be by taking subset S dash, where you have similar condition, subject to a typo, but where 6 is replaced with 0. In which case, that will be the orthogonal complement subspace, which we studied with you on Tuesday.